modern astrophysics is currently wrestling with an enormous problem. When we observe the cosmos, the vast majority of the mass required to make the universe function is completely missing. This document highlights the scale of that mathematical deficit. When running standard equations, scientists realize that exactly 85% of all matter is completely unaccounted for. Mainstream science labels this invisible void dark matter. When viewed through the lens of a simulated reality, this missing mass represents a critical system error in the universe's baseline execution. Physicists reach a dead end because they are hunting for a physical particle. If we view the universe as code, this missing mass becomes a potential sign of a software failure. This diagnostic sketch breaks down the specific mechanical failure. Under classical gravity algorithms, stars on the outer edges of spiral galaxies are rotating far too fast. There isn't enough visible mass to keep those systems tethered. They should be flung out into the void. To keep mathematical models from falling apart, mainstream cosmologists invent an invisible placeholder substance, assuming it must exist to make the equations balance. This graphic shows the opposing camp. Alternative models like MOND theory take a different yet equally flawed approach. They see the anomaly and attempt to rewrite the base laws of gravity entirely. Both scientific camps will remain stuck in a loop. They are treating a digital software rendering issue as a physical hardware problem. We can pinpoint the exact historical trigger for this system error by looking back to the Renaissance Boudette sequence. When the simulation first launched, the starry canopy, what game developers call a skybox, was optimized exclusively for low-resolution observation by the naked human eye. The crisis began when avatars in the simulation, figures like Galileo, started constructing and utilizing optics to look deeper into space. This new technology acted as an unauthorized expansion of the simulation's render distance. It forced the system to perform a high-resolution optical analysis of the background skybox. This UI overlay illustrates the resulting engine overload. When scrutinized at this newly unlocked resolution, the procedurally generated galaxies overloaded the basic gravity algorithms, threatening a total system crash. Human technological advancement broke the simulation skybox simply by looking too closely at the background assets. The developers faced an immediate dilemma. Reprogramming the entire physics engine just to fix the galaxies would have triggered countless cascading bugs across the rest of the simulation. This diagram maps their solution. Instead of fixing the core mechanics, they injected a hard-coded invisible variable directly into the galaxy code, a quick hotfix. This factor X simulates precisely enough extra invisible mass to hold the visual structure of the galaxies together under human observation. This split diagram identifies the anomaly. Dark matter functions as a hasty, undocumented spaghetti code patch deployed to keep the universe from crashing. This table compares the three major cosmological frameworks side by side. Mainstream science assumes a missing physical mass, while alternative models assume broken gravity. Only the simulation framework successfully resolves the anomaly by recognizing it as a procedural rendering error. This shifts how we must approach astronomy. When you look up at the night sky, you are not observing a massive physical universe. The vast invisible mass holding those glowing spirals together is nothing more than digital duct tape, keeping a highly unstable optical backdrop from falling apart. We need to stop trusting the generated historical lore. It is time to look past the rendering and start analyzing the code for the next glitch.